Alright, let's take a look at what humanoid robots from the most famous brands are up to. Tripping downstairs, falling on their heads or arms, losing control, collapsing, and being unable to get back up, even performing dangerous actions around humans. It's truly unbelievable. Meanwhile, look at the Tesla bot. Not only on stage at the 2025 shareholders meeting, but more than a year ago, it was already capable of performing smooth, professional dance moves that rival those of humans. The important thing is this is just the prototype version of the Tesla bot. And as Elon Musk confirmed, version 2.5 is still unfinished. The official retail version will be the Optimus Gen-3, priced under $20,000, and is expected to launch in the first quarter next year. Additionally, Gen-4 and Gen-6 have already been assigned clear timelines featuring refined design and near-human-level agility. And here are the exact timelines for all Tesla bot versions. When you see Optimus 3, it will seem as if there's someone like a person in a robot outfit. Optimus 4, you hopefully starts production in 27, and then Optimus Gen-6 inches 28. So, it's kind of like an annual release cycle with significant improvements. So, what tasks will each Tesla bot Gen-3, 4, and Gen-6 handle? What will be the specific price for each version? And why is Elon Musk focusing on homemaker and surgeon roles first? Welcome to Auto Fusion. The scale of Optimus, like I said, that's really going to be something else. I think it's going to be the biggest product of all time by far, like bigger than cell phones. At the 2025 Tesla annual shareholders meeting, Musk unveiled a series of updates and plans for the Tesla bot. As he stated, Tesla bot could one day become even more widespread than smartphones and might even help eradicate poverty through the valuable work it can perform. So far, even though it is still in the prototype stage, the Tesla bot is already fully autonomous, capable of operating and performing tasks like a household caretaker, delivering packages, watering plants, participating in service activities, cooking, fetching items, and cleaning the house completely independently without human supervision. According to Elon Musk, it is fully capable of doing virtually anything, including taking care of pets, walking dogs, babysitting, mowing lawns, or performing rescue and emergency tasks. Tesla has revealed that the Tesla bot Gen-3 will start with around 1,500 pre-installed useful tasks, expanding up to 3,000 tasks through completely free updates. This initial commercial version will focus heavily on those everyday, domestic, and foundational labor tasks. The expected price point is under $20,000, which makes it accessible for mass production and adoption as a household utility. Meanwhile, the Optimus Gen-4 is really the one we should be talking about, as it will be a more advanced, feature-rich, and nearly twice as intelligent version compared to Gen-3. The number of useful tasks will reach up to 5,000. The text suggests a significant improvement in dexterity, noting that Gen-4's hands will have much better dexterity than Gen-3, allowing it to perform jobs that require high precision, such as assembling small components or tasks requiring delicate manipulation. This leap in precision opens the door for skilled labor in manufacturing and more complex household tasks. The price is not explicitly mentioned, but following the annual release cycle with significant improvements, it's reasonable to expect a higher price than the Gen-3, potentially ranging from $30,000 to $40,000, reflecting its enhanced capabilities and intelligence. And by the time Gen-6 reaches consumers, the task count is expected to rise to 6,500, turning the Tesla bot into a near-magical robot with almost perfect precision. This level of near-magical precision is what enables the robot to perform the most delicate and critical roles. The timeline places this release in 2028. Given its near-perfect capabilities and the implication of near-human agility, the price for Gen-6 would likely represent a significant jump, potentially in the $50,000 to $70,000 range, as it moves from being a helpful appliance to a near-human-level worker capable of highly paid professional roles. As Elon Musk shared at the meeting, the future of engineering will be carried out by robots like Optimus, not by human hands. Leaked videos show that Optimus 2.5 can not only walk and stand, but also self-balance when impacted, perform delicate operations with its fingers, sort objects, and even self-learn skills through AI simulation. This indicates that the version will feature an extremely high level of sophistication, with all lines and details of the model almost completely concealing any wires, actuation systems, or joints. Elon Musk has also previously hinted that its movements will be incredibly natural, fluid, and virtually indistinguishable from a human's. Notably, Gen 4's hands will have much better dexterity than Gen 3, allowing it to perform jobs that require high precision, such as assembling small components or tasks requiring delicate manipulation. Optimus has engineered dozens of miniature actuators inside each robotic hand, allowing for up to 22 degrees of freedom. It's not just engineering, it's biomechanics brought to life. Through intensive training by Tesla engineers, the robot learns that a knife is used for cutting, a jar holds sauces, and a pan is for cooking. This information is stored and processed within Optimus's central AI brain, which allows it to make real-time decisions and execute each step with remarkable precision. Using an advanced network of cameras and 3D sensors, it can recognize objects not just by shape, but by function. Elon Musk emphasized that the human hand is a masterpiece, extremely dexterous and delicate. Replicating it is the biggest challenge, but he believes Tesla is the only company that currently possesses all three of those pieces: engineering of the arms and hands, artificial intelligence in a real-world environment, and the ability to achieve mass production. Every movement, from reaching for a utensil to turning on a stove, is the result of millions of micro-calculations happening in fractions of a second. The reason Elon Musk is focusing on homemaker and surgeon roles first is a strategic choice based on two key factors: market volume and precision requirement. Homemaker, household caretaker, general labor role. This is the Gen 3's primary target. The homemaker role represents the largest potential market volume imaginable, bigger than cell phones, as Musk stated. If the robot can perform everyday chores like cooking, cleaning, gardening, and fetching items, it has a purpose in nearly every household globally. Starting here allows for mass production at the aggressive price point of under $20,000. Furthermore, the initial household tasks serve as a proving ground for the robot's autonomy, self-learning capability, and interaction with an unpredictable environment, a home, which is a necessary step before tackling more critical, high-stakes environments. The ability to learn new tasks by simply watching a YouTube video, a feature proudly claimed by the Gen 3, makes it a highly adaptable household assistant. Surgeon role, high-precision labor. ISE, this is the ultimate goal, likely achievable with Gen 6. The focus here is on showcasing the extreme precision and reliability of the hardware and AI. Musk's statement that Optimus could eventually become a surgical robot with near-absolute precision highlights the faith in the advanced engineering, specifically the hands with up to 22 degrees of freedom. A surgeon role is the most demanding test of precision and control. If Optimus can perform surgery flawlessly, it can perform any other precision assembly, manufacturing, or laboratory task. This high-value application also serves as a long-term goal that justifies the continuous, significant annual improvements and investment in the technology's sophistication. The precision required for assembly of small components, Gen 4 capability, is a stepping stone to the absolute precision needed for surgery. Gen 6 potential. In essence, the strategy is to capture the vast consumer market early with the cost-effective, task-learning Gen 3, the homemaker, while simultaneously striving for the technological pinnacle of the Gen 6, the surgeon, to prove the robot's ultimate capability and unlock industrial and medical sectors. If the control systems, sensor data, or decision-making algorithms of Optimus were ever leaked or hacked, the consequences wouldn't just be physical damage. They could pose a direct threat to human safety. This is why Elon Musk and Tesla are building a comprehensive, multi-layered security ecosystem. It includes data encryption, real-time monitoring, AI firewalls, and automatic safety lock mechanisms that activate whenever abnormal behavior is detected. However, what's truly noteworthy is that unlike electric vehicles or standard software, a humanoid robot can learn and self-adjust its behavior through machine learning. Every advancement in the robot's cognitive abilities also means an increase in security risks. Over the past few years, Tesla has almost silently torn down and rebuilt Optimus from the inside out. Gone are the slow, stiff movements of the 2021 to 2022 versions. The current Optimus has become an extremely sophisticated mechanical and artificial intelligence system where every movement is smooth, precise, and purposeful. Some engineers have shared that they put Optimus on tasks where even new human factory workers were fumbling, and the robot handled them so smoothly that everyone was left in silence. This level of precision is exactly why Elon Musk stated that Optimus could eventually become a surgical robot with near absolute precision. How has the Tesla bot Gen-6 been upgraded for homemaker tasks? We bet you've never imagined a future where robots are not only intelligent, but can also learn faster than humans. Yes, it sounds a bit scary, but at the same time, it's incredibly impressive. Tesla's first commercial version, the Tesla bot Gen-3, proudly claims it can learn 100 new tasks every single day just by watching videos on YouTube. Optimus has the ability to watch videos, whether they're YouTube clips, instructional tutorials, or any kind of visual content. And just like a human who can learn by observing, it can translate what it sees into action. This opens up an astonishing potential for task expansion because it can learn virtually anything with remarkable speed. It might sound unbelievable, right? But whether it's cooking, repairing machinery, tidying up a house, or even dancing, there seems to be virtually nothing beyond the reach of this humanoid robot. Recently, Tesla released a new demo video showcasing Optimus performing a wide range of tasks, impressively further solidifying its potential as a remarkable household assistant. The demonstration has sparked massive excitement and anticipation for the robot's official launch. You might think, oh, someone just told it what to do. And you'd be correct. Voice commands such as pick up the broom and sweep the floor were issued, and Optimus executed them precisely. Yes, it responds to both voice and text commands. But what's truly noteworthy is that it can carry out these tasks based on very simple instructions. This represents a major leap forward, demonstrating that Optimus can handle complex coordinated movements. Even though its hands do not yet possess 22 degrees of freedom, coordinating both hands requires a significantly higher level of dexterity compared to using just one. Previously, Optimus primarily relied on one hand for simpler tasks, such as picking up objects or sorting components. Now, it can process and respond to signals from both hands simultaneously, much like a human naturally coordinating left and right hand movements. Instead of relying on traditional methods like motion capture, where humans wear sensors to replicate movements, or remote control, where someone manipulates the robot from afar, Tesla has adopted a much smarter approach. Optimus simply watches humans perform tasks in videos and figures out how to replicate them on its own. It's like going on YouTube to learn how to fix a leaky pipe or make a pizza. For Optimus, it all starts with simple tasks: taking out the trash, pulling the curtains, stirring a pot, or using a vacuum cleaner. Just like a person, Optimus can learn new skills, actions, and tasks, provided it is shown how to do them. The process is truly remarkable. For instance, if you want Optimus to learn how to cook a steak, Tesla provides a video of a chef preparing the dish. Then, in a simulated environment, Optimus practices cooking that steak billions of times, experimenting with different chopping techniques, seasoning methods, and cooking approaches. Each time it makes a mistake, its AI adjusts and improves. Once it reaches a near-perfect success rate, say 99%, Optimus is ready to perform the task in real life. This type of training allows it to learn much faster than traditional methods. Now, if you're someone who prefers hands-on teaching, you can actually train Optimus directly, especially if you own one yourself. Beyond simply providing videos, you can guide it through tasks in person. Imagine saying, "Hey, can you help me iron this shirt?" You would demonstrate once how to turn on the iron and move it across the fabric. Optimus observes, analyzes, and attempts the task. If it makes a mistake, you correct it. No, you need to move the iron this way. It remembers and improves. Sure, at first it may ruin a few shirts, but that's part of how a humanoid robot learns and develops its skills. The implications of this are enormous. Think about the everyday chores that occupy so much of our time: laundry, cooking, cleaning, or even simple organization. With Optimus, all of these tasks could one day be automated without the need for explicit programming for every single action. By observing and practicing, the robot effectively teaches itself while refining its performance, much like a human apprentice gradually mastering a craft. Moreover, the flexibility of this learning system is astonishing. Optimus isn't limited to a predefined set of skills. It can continuously expand its capabilities as new content becomes available. Every new instructional video uploaded online is a potential lesson, enabling with the robot to adapt to trends, learn new technologies, or even acquire new hobbies. Its learning is cumulative and scalable, which is a stark contrast to traditional automation methods that are rigid and task-specific. Tesla's approach also highlights a deeper shift in how humans might interact with robots in the future. Rather than programming precise instructions, we will teach robots in ways that mirror how humans teach each other through demonstration, repetition, and guided correction. This creates a more natural and intuitive interface between humans and machines, where the robot is an active learner rather than a passive tool. In addition to household assistants, the implications for industrial and service sectors are equally significant. Optimus could learn specialized tasks in factories, laboratories, or healthcare facilities simply by observing trained professionals. This could drastically reduce training costs, improve efficiency, and make highly adaptable robotic workforces a reality. These are the latest updates on the Tesla bot lineup to date. Now, let's turn to the technology Tesla is prioritizing most for the year ahead. As Elon Musk has confirmed, humanoid robots and the cybercab will be the company's two main development focuses in the near term, with Tesla dedicating roughly 85% of its resources to advancing these projects. Tesla is betting big on redefining both personal robotics and autonomous transportation, and the company is putting its weight behind turning that vision into reality. What breakthroughs has Tesla Cybercab production achieved? The Cybercab's production methodology marks one of the most significant innovations in modern vehicle manufacturing. Rather than following the conventional assembly line approach, where vehicles move sequentially through each production stage, Tesla's unboxed process builds major vehicle sections in parallel at different stations and combines them only during final assembly. This parallel module assembly system allows multiple engineers and automated systems to work simultaneously on different components, dramatically reducing both production time and factory space requirements. The battery solution also addresses supply chain resilience concerns